Next problem says A, B, C are distinct integers. Prove that there is no polynomial p of x which coefficients are integers, and p of a is b, p of b is c, and p of c is a. You understood the problem is what?
Yeah.
Okay, so try this problem.
I don't know how to prove this.
Okay, so let's try. Can you say what have you reached?
I didn't really reach a lot. I said x minus b times q2, or x minus a times q1
A
x.
minus b divides what, for example? By previous
A
theorem.
Oh, okay. It divides b minus c.
Yes, p of a minus p of b, which is b minus. So like this, you can write other things. Want more hint or that's enough?
I'll try for.
Okay.
Well, then you would have three terms that cyclically divide into each other, which doesn't work.
Exactly. A minus b divides b minus c. A minus c divides what?
Oh, I said b minus c divides. I said b minus c divides c minus a, and c minus a divides a minus b.
B minus a
Which
divides b minus c. Yes. So then what?
wait, c minus doesn't c minus a divides a minus b.
No, c minus a divides p of c minus p of a. P of c minus p of a is a minus b or b minus a. That's right, a minus. Agree?
B. Yeah. So now they're it's cyclic.
Yes.
So
Then what?
how do I prove that doesn't work?
So because cyclic, you can say what?
A minus b divides a minus b. So they're all equal?
Not necessarily.
Not necessarily. A minus b divides b minus c divides c minus a divides a minus b. Doesn't a minus b have to equal b minus c equals c minus a?
Look, then a minus b divides, for example, look, we know b minus c is equal to, for example, a minus b times k, right? Or
Yeah.
k1. C minus a is equal to b minus c times k2, right?
Yeah.
And again, a minus b is equal to c minus a times k3, right?
Yeah.
So if we plug in the a minus b from here is c minus a times k3 k1. C minus a is b minus c times k2 k3 k1, right?
Yeah.
So then what can we conclude?
K2, K3, K1 is 1.
Exactly. So two of them. So then what can we conclude?
One of them is equal to no. Wait, what can you conclude? They're not necessarily integers. I don't know.
Okay, so look, k1, k2, k3 are integers, right?
Why are they necessarily integers?
Because when we work with divisibility, all things are integers. A, B, C are distinct integers. A minus B divides this one, two integers divide each other. The definition when you write k1 is integer. So Because if you don't
Okay.
write, if k1 is not integer, it doesn't mean, for example, look, you say, okay, 3 is 2 times 3 over 2. So 2 divided 3, but that's right? It should be integer, right?
Okay.
So
Yeah.
when we write divisibility, divisibility is only for integers, okay?
Okay.
So this one is multiple of this one. So this one is a minus b times something. And k1 is integer. So k, what are the cases of k1, k?
1, 1, 1, or 1, negative 1, negative 1.
Exactly. Or 1, negative 1, negative 1. Or 1, negative 1, negative 1. We have these 4 cases, right?
Yeah.
Okay. So the rest is not hard. Try the rest.
So first case you would get A equals B, so it's wrong. And check the other ones
Ah,
now.
okay, because for this one, we know a minus b minus c. Okay, so for the first case, a minus b is equal to b minus c is equal to c minus a, right?
Yeah.
From these two, we can conclude a plus c is 2b, right?
Yeah.
And from similarly, we can conclude that a plus b also is 2c, right?
Yeah, you can say B equals 2C minus A. And then you would
Or
get 3A
we
equals
can also
3C.
write it as this. We have lots of generalities. Suppose a is greater than equal b greater than equal c, okay?
Okay.
And then we agree b plus c is equal to 2a if we consider this one and this one. B plus c
Yeah.
is 2a, right?
Yeah.
And we know b plus c is at most 2a, right?
Yeah.
So because these inequalities, you can conclude a is b, c, right?
Yeah.
And that's a contradiction. What else? Case 2.
You get B minus C equals A minus B.
Let me
And you
write.
also get
B minus c is a
or
minus b, yes.
you get C minus A equals C minus B, which is immediately means A
From
plus
here you can
B.
conclude A is B contradiction, right? So if
Yeah.
one of them is -1, you can reach easily contradiction, right?
Yeah. Yeah.
Okay, similarly for other. Similarly, yeah,